Another method we could use to simplify trig expressions is combining fractions. Here we have sin x cosine x over 1 minus sin x minus 1 plus sin x over cosine x. Boy, these are a mouthful. Anyway, looking at our denominators here, I see 1 minus sin x and cosine x. If we can get common denominators, we can combine these into one term. Looking at this denominator over here, I have 1 minus sin x, but I do not have a cosine x. So I'm going to go ahead and multiply the left, top and bottom, by cosine x. Looking at the right side, my denominator has cosine x, but it is lacking 1 minus sin x. So I'm going to multiply the right by 1 minus sin x, and of course, both the numerator and the denominator. Alright, doing that on the left, I'm going to get cosine x times this top, leaving me with sin x cosine squared x, and cosine x times the bottom, 1 minus sin x, which I'm going to leave like this. Don't distribute the denominator because it may be counterproductive. Later on, you'll see why. On the right side, we have 1 minus sin x to the top, 1 plus sin x. Don't forget, you have to distribute all of this out. That'll leave you with 1 minus sin x plus sin x minus sin squared x, and simplifying that, you'll just have 1 minus sin squared x. In the denominator, yes, we'll have common denominators now, cosine x, 1 minus sin x. Perfect. Now that we've got common denominators, let's put those guys together. Doing that, I'm going to get sin x cosine squared x minus, I put parentheses here because remember, this negative has to distribute, but before I distribute, let's just put it together because we might be able to do something with this here. That's going to be minus parentheses 1 minus sin squared x. All over our common denominator, cosine x, 1 minus sin x. Alright, going from here, I notice this 1 minus sin squared x. Now this is why I didn't distribute, because when I see a 1 and a sin squared x, I immediately think of my Pythagorean identities. If I rearrange this, sin squared plus cosine squared equals 1, I will have cosine x, cosine squared x, equals 1 minus sin squared x. That will allow me to replace this cosine x for my 1 minus sin squared x. Doing that, I'm going to be left with sin x cosine squared x minus, remember I replaced this here with cosine squared x using my Pythagorean all over our common denominator. Now, looking at my numerator, I see that I have a cosine squared x in this first term and a cosine squared x in this second term. That means I could factor one of those out. That'll give me a cosine squared x on the outside with a sin x minus 1 on the inside, all over cosine x 1 minus sin x. Looking at this, I see a cosine squared x over a cosine x. One of those cosines can cancel. That's going to leave me with a cosine x, sin x minus 1, all over 1 minus sin x. Now, this sin x minus 1 over 1 minus sin x, they almost could cancel, except they're the opposite. So, remember, when this is the case, we just need to flip these around. We can factor out a negative and switch them up. That's going to leave us with a negative cosine x. And because I factored out a negative here, now I can switch these around, leaving me with 1 minus sin x, all over 1 minus sin x, which is perfect, meaning these two are going to cancel out. And after all that work, I'm simply going to be left with negative cosine x.